All right, hello everyone. Math lesson, April 27th, 2020. We're gonna start with our fluency at the bottom. The first one, number one, solve the following multiplication problem. All right, so multiplying. When you're multiplying, you do not need to line up the decimals. So in this case, 3 4/10 times 7. Let's multiply. Now let's see. 7 times 4 is 28. We're gonna put our 2 up here, carry our 8 below. 7 times 3, 21, plus 2, 22, 23. We'll write that down here. That is not your answer because we have a decimal up here in only one. So we're gonna put our decimal in only one place in our answer, in our product. So our answer is 23 8/10, or 23.8. That would be number one. Let's go to number two. Remember, you can pause, rewind, whatever you need to do through this. Number two, I need to zoom out just a little bit there. Number two, Jose received $30 for his birthday. There we go. $30 for his birthday. Nancy received $20 for hers. They went to the mall where they saw the following items in the table below. What is the most money Nancy, so we're gonna look at Nancy, she received $20. The most money that Nancy could come home with if she bought only one item. And then it says, what is the one item that she could buy? Well, if you go to the store and you wanna buy something and bring home the most amount of money, you wanna buy the cheapest item. So let's see, which is gonna be the cheapest? The baseball cap, $5.98. T-shirt, $8.98. Sweatshirt, $10.25. Or a CD, that's $6.98. Well, the cheapest item would be a baseball cap. So I'm gonna circle this here, and the item that she could buy is a baseball cap. So you can write baseball cap. And then you can put a comma in your answer document, and we are going to find out the most money that she can come home with, which means we are going to subtract. So $20 is what she has, and we're gonna subtract the $5.95. Notice how I'm lining up the decimal because we are subtracting. All right, so 0 minus 5, you cannot do. We need to borrow. Oh, we need to borrow. Oh, we need to borrow. This 2 becomes a 1 to make this a 10. Now we can borrow from this 10 to make it a 9 to make this one a 10. Now we can borrow from this 10 to make it a 9 to make this a 10. I know, pain in the butt. If you do it your other way, go ahead. 10 minus 5 is going to be 5. We're going to drop our 5 there. 9 minus 9 is going to be a 0. So we're going to put our 0. Drop the decimal down. Drop it like it's hot. Not 5 minus 9. 9 minus 5 is going to be 4. And 1 minus 0 is going to be 1. So $14.05 is what she will be coming back with. So you can put your baseball cap and then 14.05. You can put the dollars if you like. However you want to enter that is absolutely fine. All right, again, you can pause, you can rewind, whatever you need to do. I'm gonna move on to our daily math review. DMR, let's look at number 3. Maddie solved the expression below. Her teacher marked it incorrect. That means she marked it wrong. Poor Maddie. Help Maddie determine the error that she made. Ooh, so this says 2 to the 5th power. So when you have 2 raised to the power of 5, that means 2 times 2 times 2 times 2 times 2. So, right? So 2 to the 5th power. We're going to see that 2 5 times. 1, 2, 3, 4, 5. Okay, good. And they're all multiplying. Yes. All right, so let's see what she did. So she did 2 times 2 to get 4. Yep. And then she did another 2 times 2 to get 4. And then she did 4 times 4 to get 16. Uh-oh, what did she forget? She forgot the times 2. So we are going to multiply it by 2 because we need to bring that down. She forgot that. So 16 times 2, you can write it off to the side. 2 times 6 is going to be 12. 2 times 1 is 2, plus 1 is 3. So 32 is your answer. So Maddie forgot the 2, forgot to multiply it by another 2. So our correct answer would be 32. All right, number 4. Wow, we're going through this pretty quickly. Good job. Solve the following using the order of operations. Woohoo! Woohoo! Order of operations, please excuse my dear Aunt Sally. Now remember, when you are doing the order of operations, we have parentheses, we have exponents. Multiplication and division, you always go from left to right. It doesn't matter which one of these comes first, the multiplication or the division. You always go from left to right, so whichever multiplication or division comes first. Same thing with addition and subtraction, whichever comes first in your problem. So whether it's addition or subtraction, maybe subtraction's first, that's fine. Since these two are next to each other, they could go either or. So you always go from left to right. From left to right. All right, now let's take a look. Do we have any parentheses? Woo! Bingo, we have parentheses. So inside our parentheses here, let's do green. Inside our parentheses here, we have 1 plus 3. Well, 1 plus 3 is 4. Woohoo! All right, so now I'm going to bring everything else down that we did not use yet. Bring everything else we didn't use yet. We didn't use this third power here, so I'm going to keep this in parentheses. And then I'm going to keep that 2 out there. And then I'm going to bring down our minus 5 squared. This one is a little tricky, so make sure you're paying attention. Now, do we have any more parentheses? Well, we do. However, everything inside the parentheses is solved. So that means we could be done with that step. Everything in the parentheses is solved. Let's go to exponents. Do we have exponents? Yes, we have an exponent here and an exponent here. So this exponent is only attached to this 4. This exponent is only attached to this 4. So that means 4 to the third power. So I'm going to write it on the top up here. 4 to the third power means 4 times 4 times 4. Well, if we have 4 times 4, that's 16. Bring down your times 4. 16 times 4, let's do it. 4 times 6 is going to be 24. 4 times 1 is 4, plus 2 is 5, 6. So 64 will be this answer here. I'm going to bring everything else down that I didn't use. Now, we did not use the 2, and then these parentheses means multiplication. So remember when we used the distributive property, how you would take that and you'd multiply it by everything on the inside? So this, we're just going to write down this 2, and then I'm just going to replace the parentheses, since they're right next to each other, with the multiplication symbol. Minus 5 squared. Now, in this case, you can solve the other exponent, but I brought it down because if you forget, it's not a big deal to just go back and do it again. So 2 times 64 minus 5 to the second power, 5 squared. Do we still have exponents? Yes, we do. So this exponent, 5 squared, means 5 times 5. So 5 times 5 is 25. Bring everything else down that you did not use. So our subtraction, 64 times 2. Woohoo, we're getting there. All right, now when we do this, do we have any more exponents? Nope. Bingo. Do we have any multiplication or division? Yes, we have multiplication, and that's the only thing we have of multiplication and or division. So we're going to do the multiplication first. 64 times 2, or 2 times 64. 2 times 4 is 8. 2 times 6 is 12, so 128. Bring everything else down we didn't use, minus 25. Now, our last step here, 128 minus 25. So we're done with our multiplication and division. We are now down to addition and subtraction. So 128 minus 25. 128 minus 25. Now, in this case, yes, you can line up the decimal. You can think of it as 0.0. Or make sure you line them up by, so the 8 is in the ones place. Same with the 5. So the ones need to be lined up. The tens need to be lined up. The hundreds need to be lined up. So make sure you're lining everything up. 8 minus 5 is going to be 3. 2 minus 2 is going to be 0. And 1 minus 0 is going to be 1. So our answer here is 103. You might want to try it on your own. Go back through this. Whatever you want to do to help you would be amazing. Remember to follow all the order of operations until you get to your answer. All right, here we go. We're going to go to our air practice review. Number 5. Wow, look at this stud muffin of a figure. Which solid can be made from the above pattern? All right, so a solid, or our 3D figure. So when you fold this up, when we name a solid, we always name it by the base. So in this case, our base is this blue area. So that base, what shape is that base? Oh, it's a square. Okay, so it's a square base. And then the sides are, yeah, they're triangles. If we fold them up, it's gonna look like a pyramid. Ooh. Whoa, that was a bad pyramid, but you get the gist. So when you fold it up, it will be a pyramid, and the base is a square. So this figure is going to be a square pyramid. So our answer is D, a square pyramid. All right, so just like the pyramids over in Egypt, you know, when it comes up to a point, you will have a pyramid. And the square is our base. Let's look at number 6. Wow, we are flying by. I'm so proud of you guys. Number 6, here we go. So using the dimensions shown, you could create a rectangular prism. Ooh. So when you fold this up, you'll get a rectangular prism, or like a Christmas box or a birthday present box. Ooh. We're going to calculate the surface area. So the surface area, remember, is all of the material for the outside. Everything with the outside will take space. So, for example, the wrapping paper for the Christmas present around the box, that's what surface area, that's what we're covering. The wrapping paper is covering the surface area. So let's take a look. When you have this side is 10 and this side is 3, you can do this a bunch of different ways. You can draw them out separately. You can write on it. I'm going to write on it just because you can write it out on your paper, but just so I can save a little space. So when you get the area, we're going to find the area of each of the different shapes, and then we're going to add them together, because that's how much technically wrapping paper is going to go on around the outside, the surface area. So this base times height, or length times width, for a rectangle, that's the area of a rectangle, 10 times 3, what's 10 times 3? 30. So I'm going to put 30 here. So we have a 30. Now, if this is 3, when it folds up, it's going to connect to this side. So this side is also going to be 3. And then since this side is 2 over here, all of these sides are going to be 2. You see that? This side is 2, so all of these sides are going to be 2 because they're the same length throughout. So 3 times 2 is going to be 6. So this little area is going to be 6. As well as over here, it's the same thing. 3 times 2 is going to be 6. All right, so I'm going to write on the side, we have a 30, we have a 6, we have another 6. Okay, now if we look up here, this is also the same shape as this bottom one. So 10 times 3, this will be 10, this will be 10, this will be 10. So 10 times 3 again is going to be 30. So we have another 30 up at the top. So I'm going to put another 30 here. Now we have 2 more boxes here, 2 more surface areas. So 10 is the base here, and the height is 2. Remember this, all these are 2. So 10 times 2 is going to be 20. All right, so we're decoding it. And this is also the same shape. 10 times 2, when you fold it over, it's going to be 20. So I have 20 and then 20. And we're going to add them all together, just like we're adding up all the sides of our Christmas present box. So 0 plus 6 plus 6 plus 0 plus 0 plus 0. So it's really 6 plus 6, which is going to be 12. 12. 3 plus 3 is going to be 6, 7, 8, 9, 10, 11. So our answer is going to be D, 112 meters. Now remember, all these sides are meters. So when you have the surface area, so all the outside, it's just going to be meters squared to the second power, because it's just a 2D shape. We're just finding the area of the outer. Now, if it was the volume, meaning all of the space on the inside, that would be cubed, because we have 3-dimensional figure that we are going on the inside that we would be measuring. But this is only the outside, only the wrapping paper. The wrapping paper, it's just all 2D, so it's going to be 112 meters just squared there. You can put D on your answer sheet. All right, woohoo! Let's go to the last one, number 7. Bop, 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 bop. I hope you liked that little noise during our quarantine here. Okay, so Deborah takes apart a shipping box so that she can reuse the cardboard for an art project. Ooh, how fun. The figure below shows the disassembled box. So the box is not folded up, obviously. What is the total surface area in square inches of this box? Yay, we know how to do that. All right, so what we can do is label all the sides if you want. Remember, this is going to be 9, so this will be 9, this will be 9, this will be 9, this will be 9. If this is 4 and this is 4, this is a square. So remember, if you fold this up, then that will be a 4. Because they will fold up and they'll fold together. So 4, that'll also be a 4. Then when you go across, that will also be a 4. This will be a 4, this will be a 4, a 4, a 4, a 4, 4, 4, 4. Woo! Lots of 4s there. All right, let's see. So let's find the area, the surface area. So we're gonna find the area of each of the blah, 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 each of the smaller boxes, and we're going to add them together. So 4 times 4 for the square, easy. 4 times 4, 16. Same thing over here, 4 times 4, 16. That's the area of the square, base times height or length times width. So I have a 16 and then a 16. 9 times 4 is going to be the area of this figure. So 9 times 4, when you have 9 times 4, you get 36. All right, and then this is also 36 because this is 9, this height is 4. So 9 times 4, again, 9 times 4, 36. 9 times 4, 36. Whoa, genius. Brilliant. All right, 36, 36, 36. 1, 2, 3, 4. Okay. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Perfect. 6 plus 6 is going to be, well, actually, if these are all 6s, we can do 1, 2, 3, 4, 5, 6. So 6 times 6 is going to be 36, or you can add them up. 6 plus 6 is 12, 18, 24, 30, 36. So let's do a different color. We have 36, 3, 6, 9, 12, 13, 14, 15, 16, 17. So our answer here is 176 square inches. That's how you should want to write it on in your Google Doc. But if you were to write it on paper, that could also look like this, 176 inches squared. That also means the same thing. All right, have a wonderful day.